Morning, everyone. Good morning. Hope all is well. Hope everyone's doing all right.
Good morning.
How's it going? How's it going? All right. So wait for everybody to get in here and then we'll go ahead and get started. Let's see. All right, looks like everybody's in here. So we're gonna go ahead and finish off 6.2. And if we have time, we'll and we'll go ahead and touch on a little bit of 6.3, not to finish 6.3, but go ahead and start it a little bit just like we did last time. So once again, we're still in 6.2. We're solving equations. Want to give you a few more scenarios. We're starting here. 5x minus 12 equal to 8x plus 24. All right, so if you remember the problem that we had last time, if we go back, notice we had more than one variable, but they both were on the same side. So we were able to combine like terms with no problems. This time we have more than one variable, but both of them are on different sides of the equation. So our goal here should be to get all of our terms with the variable on one side of the equation, all of our terms without the variable to the other side. So, and it doesn't matter which one you move first, which side you take it to, as long as you stay correct with your mathematics, you'll still get the same answer. So notice we have 4 different terms here. And like I said, it doesn't matter which one you decide to move, as long as you do it correctly, you'll still get the same answer. So I'm going to go ahead and subtract 8x from both sides. I'm trying to move the whole 8x, so I subtract 8x from both sides. 5x minus 8x gives me negative 3x minus 12, and then a negative 8x cancels out on the right, leaving me with just 24. From there, add 12. 12s cancel. Leave me with negative 3x equal to 36. And then we finish it off by dividing both sides by negative 3. X is equal to negative 12. Any questions on that one before we go to the next one? Looking at the next one, we have 2 times the quantity of x minus 3 minus 17 equal to 13 minus 3 times the quantity of x plus 2. So first thing we'll do is distribute the 2 and then distribute negative 3. So be careful here. Make sure you distribute the negative with the 3. They are attached to each other. So we have 2x minus 6 minus 17 equal to 13 minus 3x minus 6. Right. Best practice here is to simplify as much as you can on the left Simplify as much as you can on the right before you move things across the equal sign. So negative 6x and negative 17 gave me negative 23. And then here, 13 minus 6 gave me 7. So now I have 2x minus 23 equal to 7 minus 3x. Now, once again, we have more than one variable on different sides of our equation. Goal is to get all of your terms with x on one side, all the terms without x to the other. So I'm going to add 3x to both sides. That gives me 5x minus 23 equal to 7. Add 23 to both sides. And I have 5x equal to 30. And finish it off by dividing both sides by 5. And x is equal to 6. All right, any problems before we go to the next one? We gotta go with the last one, scrolling up. So this next one, we have 3x over 2 equal to 8x over 5 minus 4. So whenever you have a problem dealing with fractions, you can handle it one or two ways. Either you can just work the problem with the fractions involved, or you can do what we call clearing out your fractions. All right, so we'll go through the steps of doing that. First thing, if you want to clear out your fractions, is that you have to find your LCD. And so you notice over there in the blue, gave you a little reminder of what that is. That's the smallest number that each denominator can divide into evenly. So our denominators are 5 and 2. So you say, what's the smallest number that both 5 and 2 can divide into evenly? And that's going to be 10. And so our LCD is 10. So second step is going to multiply each numerator by the LCD. So notice we said numerator, I'm not multiplying top and bottom of the fraction, I'm multiplying across the equation. So I'll multiply each numerator by 10. So now we can simplify. The 2 divides into 10 and leave you with 5. 5 divides into 10 and leave you with 2. And now I'm left with this equation, 5 times 3x equal to 2 times 8x minus 10 times 4. Simplify that, and that'll be 15x equal to 16x minus 40. And so that'll be our most simplified way of expressing this equation. And now we can solve it without fractions. Also, I didn't point out, don't forget when you multiply across your equation that you don't forget the terms that don't have a fraction. Sometimes people do forget that the ones without fraction need to be multiplied by the LCD as well. Every single term in your equation has to be multiplied by the LCD, even the ones that don't have denominators. So be careful with that as well. Any problems before we go to step 4? All right, to solve, I need to get all of my variables, all of my terms with X to one side of my equation. So I subtract 16X from both sides. And that will give me negative X equal to negative 40. And remember, we're solving for X, not negative X. So we will take the negative to the other side. Negative to negative turns positive. So it's X equal to 40. Any questions before we look at the next one? Scroll up. All right. So the next one is 20 over X minus 10 equal to 30 over X. So this one's a little different than the last one. If I have one solid fraction equal to one solid fraction, I can cross multiply. If you go back to that last one, we had a -4 over here. That stopped us from being able to be in that type of situation. So whenever I have one solid fraction equal to one solid fraction, I can cross multiply. And that's what I did right here. You always take your denominators up to the opposite numerator. So it'll be 20X equal to 30 times X minus 10. All right. Once you've done that, you can go ahead and solve, distribute 30. That'll be 20X equal to 30X minus 300. Subtract 30X from both sides. That'll be negative 10X equal to negative 300. And then divide by negative 10, that'll give us 30.
Will the answer always be positive instead of negative?
No. Now your X will always be positive, or your variable will always be positive, but your answer could be negative. You could have X equal to -5 or something like that. That's fine.
Oh, okay.
But you don't want negative in front of your X.
Okay. Thanks.
Yeah, no problem. Good question. Good question. All right. And go to the next one. Everybody good? All right, so we have two more scenarios that I want to make sure we cover. And these next two are special scenarios. So let's see how these turn out. So we have 2x equal to 6 equal to 2 times x plus 4. So the first thing we're going to do is distribute. And that gives us 2x plus 6 equal to 2x plus 8. So now we're going to subtract both sides, subtract 2x from both sides. So notice it ends up canceling on both sides. So be careful. Sometimes people are afraid to let that happen. It is okay for your variables to cancel on both sides of the equation. Notice that leaves us with 6 equal to 8. And that is a false statement. So your answer isn't false, but you have a false statement, of course, because 6 is not equal to 8. But we have a special situation here. So whenever your variables cancel and you end up having a false statement, your answer is no solution. Excuse me. So once again, whenever you do your solving, your variables end up canceling out completely. You end up with just numbers. You'll have a true or false statement. If you end up with a false statement, your answer is no solution. Any questions on that one? All right. Last one out of this section, we have 4x plus 6 equals 6 times x plus 1 minus 2x. So distribute 6. That'll be on the right, 6x plus 6 minus 2x. Combine your like terms. So 6x minus 2x is 4x. Now subtract 4x from both sides. They cancel out on both sides and they leave us with the true statement of 6 equal to 6.
Where did the negative 2x go?
Right here, we did 6x minus 2x, and that gave us the 4x.
Oh, okay, thanks.
No problem. So your variables cancel, and then you end up with a true statement. Your answer is all real numbers.
So when we doing our assignment, will we put true or will we put just 6 equals 6?
No. They're gonna have the way MATLAB will have it is that A would be like a box where you can put like 5 or 6. Like if x equals 6, you would put 6 there. Then B would be no solution, and then C would have something that represents all real numbers. So for D, you would choose B or C. Yeah.
Okay, thank you.
Yeah, no problem. Good question, good question. So I'm glad she said that, because I do want to reemphasize that your answer is not true. Your answer will not be true statement. Your answer is not false or false statement. Your actual answer is either no solution. If it's a false statement, it's no solution. If it's a true statement, it's all real numbers. And you'll see that option when you get to these assignments in MATLAB. Yeah. Questions, any questions, any questions? Everybody good, everybody straight. Okay, so as always, try some of these problems out, see if you get stuck. If you have any questions, try to leave room during class time to ask them. If not, feel free to come to those office hours I sent out. Remember, there's Zoom as well. So all you have to do is click the link. Or if you have a question and you want to shoot it to me an email, if it's easier for me to just create a small video and send that to you, I'll do that as well. It's not a big deal. Sometimes I even send that video to the class if I feel like it's a problem that will help, everybody. So yeah, just feel free to ask your questions. You try the stuff out. All right, so let's step. Is everybody done copying this before we switch the page? So let's step into 6.3. Last class, we only did like 2 problems. So I'll just do that and stop here as well. Stop this way. Try to stay in the same spot. So 6.3 is applications of linear equations. Applications is another word for word problems. I know y'all couldn't wait to get the word problems. At least we only have one section of word problems, right? So first thing is the strategy. They give you a 5-step strategy in order to be able to solve. First, you want to read. Second step, and let me go back to the first step. When it goes to reading the problem, make sure you read it enough times to get an understanding as to what it is that you supposed to be trying to accomplish. Nobody knows how long or how many times it took for you to read the problem. So make sure you read it enough times to make sure you understand what you need to do and what they're asking of you. Step 2, if necessary, write expressions for any unknown in terms of X. So what's going to happen is that you could have more than one variable or more than one unknown, not more than one variable. You could have more than one unknown, but what you don't want to do is write more than one variable for each one unknown. So in other words, you don't want to do X, Y, and Z or something like that, because the more variables you have, the more equations you will need in order to be able to solve. Then you'll need a system of equations, and I'm pretty sure y'all don't want to do that right now. So we're going to take one variable and write that as many ways as we can in order to solve the equation. Then we'll write the equation. So I'll put an asterisk beside steps 2 and 3 because those will be where you have most of your challenge. Steps 2 and step 3 actually setting up the equation. Step 4 you're going to solve, and then step 5 you want to check, because sometimes you can have the actual, you can solve the equation, still have not answered the question fully, and you'll see what I mean with our first example. So you always want to check to make sure you've actually answered the question. Another good. Let's go up. Page 370. There are key phrases that will help you out as far as wording, translating words to actual equations. Remember that this textbook is an e-text, also a math lab, so you do have access to it. So all you have to do is go to the e-text, and I'll go to page 370. You'll see those phrases like sum means addition, quotient means division, stuff like that, difference is subtraction. So things like that. So you always can reference that page if you need any help with that. So here we have a word problem, and you don't have to copy it if you don't like, don't want to, but I had to put it up here so you can see what I'm talking about. I guess I'll give you a chance to write it for those who want to, but let's go ahead and read it out. It says the average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. The average yearly salary of a man with a master's degree exceeds that of a man with an associate's degree by $45,000. Combined, the 3 men earn $214,000. Find the average yearly salary of each man. All right. Are you copying that down? Anybody in Zoom copying this down? So I know if I'm waiting for anybody.
No.
Y'all always be able to reference this if you like. You have the videos, and I pulled these problems right from the examples and 6.3, so you can always go there as well. So let's go ahead and walk this thing out. All right, so the first step you want to do is identify all of your unknowns. I tried to color code it as well, so we can try to stay, cool, what's going on. You want to identify all your unknowns. So if you go back to the wording, first sentence, we have the average yearly salary of a man with a bachelor's exceeds that of a man with an associate. So we have two people right there, man with a bachelor's, man with an associate. You then go to the second sentence, yearly salary of a man with a master's and a man with associates. So we have a man with the master's, and then you reference the man with the associates again. So we have three men going on here. One has an associate's, one have a bachelor's, and one has a master's. So those are our three unknowns. Mhm. Next one, we want to write each unknown in terms of X. So this is what I was talking about when I was going through the steps. What we do not want to do is call this one X, this one Y, and this one Z. Because then I would need three equations in order to be able to solve for X, Y, and Z. So I want to write all of them in terms of X. So now each problem in this section will give you that scenario. You could have more than one unknown, but in each case, you'll be able to write it in terms of one variable. So let's go back and see how we can do that. In this first sentence, it says the man with the bachelor's exceeds that of a man with an associate's by 25. So it's referencing the bachelor's, or speaking of the bachelor's in terms of the associates. Same thing occurs with the master's. That exceeds, master's exceeds that of a man with an associate's by 45. Once again, talking about the master's in terms of the associates. So what we can do is write our unknowns in this way. Call the associates X, and then the man with the bachelor's X plus 25, and then the man with the master's X plus 45. So the associates is going to be X, the bachelor's is going to be X plus 25, and then the master's is going to be X plus 45. Any questions? Any questions? All right. Next step, write an equation. So the key word here that's going to help us do that is combine. We're talking about combining something, adding them together. So it says combine, the three men earned $214,000. So here's my equation. Now I didn't need the parentheses there. I just did that just to signify and to show each piece. So we have X, that's the man with the associates, X plus 25, the man with the master's, and then X plus 45, the man with, I said about X plus 25, the man with the bachelor's, X plus 45, the man with the master's. Matter of fact, let me do this. Let's see, color code. Any questions? Any questions? Everybody okay? Once again, those parentheses don't add any value to anything. It's just me, like I said, using those parentheses to signify. Signify what was being substituted in. All right, so is everybody good? Everybody ready to solve? So here we go. Now, like I said, I'll drop the parentheses and we have X plus 25 plus X plus 45 equal to 214. First thing we want to do is combine our like terms. X is 3X. 25 and 45 is 70. So we now have 3X plus 70 equal to 214. Subtract 70 from both sides now, and that'll be 3X equal to 144. Then divide by 3, X is equal to 48. Any problems before we go to our final step? Make sure we're okay. All right, so now we want to check. And this is important because even if we get our answer correct, as far as solving is concerned, we may not have fully answered the question. If we go back to the problem, it says find the average yearly salary for each man. So if I put in 48, it's going to mark it wrong because all I gave was one answer. So, and let me do this right here. Let me drop down. And so if I know what X is, then I can figure out what the other two are. So here's my definition for each one of my unknowns. Associates is X, bachelor's is X plus 25, master's is X plus 45. So that's what we did right here. Took 48, plug in for X to give you all three pieces. And so all three pieces also need to add up to give you 214 as well. All right. Questions and questions? All right. Let's do the next one. So next one, the toll to a bridge costs $7. Oh, somebody say something?
Yeah, so for the other question, so the answer would be 48, or will it be the answer that you got for each one?
It will be each one will be all three of them.
Okay, thanks.
Yeah,
Okay.
no problem. So there should be either they're gonna do a box for each one, or it will be, they will tell you to separate by comma,
Oh, okay.
but they would need all three of them. Yeah. Mhm.
Okay, thanks.
No problem. All right. Everybody good? Next one, straight. Okay, so the toll to a bridge costs $7. Commuters who use the bridge frequently have the option of purchasing a monthly discount pass for $30. With the discount pass, the toll is reduced to $4. How many bridge crossings per month will the total monthly cost without the discount pass be? The same as the total monthly cost with the discount pass. Sorry about that. And just to confirm, nobody's copying. All right, so let's get to it. So just like before, you want to establish your unknown. We only have one main unknown here. I won't say it like that. We have a main unknown, which is for how many bridge crossings per month. So it's letting us know right there. That's what we want to know. So you can always try letting X be that. You know, if you ever clueless and they ask you something specific, always can start there and let X be that. So you see right here in the purple, X is going to equal the number of bridge crossings per month. Mhm. So now, at that first sentence, the toll to a bridge costs $7. That's the regular price. So every time you cross, it's $7. So 7X is going to be the cost monthly without discount. If X represents the bridge crossings per month, 7 times X will be the cost without discount monthly. I guess I could put monthly there. All right. And then for the next piece, it says commuters usually frequently often purchase a monthly discount pass for $30. Now, when you pay that $30 up front, then you get a discount on the toll, which is reduced to $4. Yes. Which is reduced to $4. So that means every time you pay the $30 up front, every time you cross the toll will be $4. So in the blue, you see we have 30 plus 4X will be the cost with the discount. And so let's switch that. Mhm. So before we go any further, is it okay what we're doing here? If you want a discount, you have to pay $30 up front. And then from there, each time you cross is $4 each time. So that's why it's 30 plus 4X. If you don't do that, then you have to do 7X. You know, every time you cross, just gonna be $7 a month. I mean, $7 a time every time you cross. Keep that monthly thing. Keep wanting to say that, but all right. So we want to write an equation. The key word here is same. It says for how many bridge crossings per month will the total monthly cost without the discount pass be the same as the total monthly cost with the discount pass? So whenever you have that word the same, then you're going to be setting something equal to each other. And it's talking about these two pieces right here, 7X without the discount, 30 plus 4X with the discount. And so you set those equal to each other to solve. So from there, subtract 4X from both sides. That'll give you 3X equal to 30. Divide by 3. X equal to 10 is our answer. All right. So I'll give you a chance to write that down and interpret what that means, why that's the answer, and all this stuff like that. So this 10 is our answer. It's not like last time where we had to put in X in different spots. X represents the number of times that you cross the bridge or the toll monthly. The reason why something like this is important is because remember, if you want to do the discount, you have to pay $30 up front. Well, this right here lets us know that if I'm going more than 10, then the discount is going to be worth it. If I do not go over the total more than 10, then it's not worth it because I'm still going to pay less than what I would pay with the discount. So if you don't want to pay that $30 up front, this is how something like this would be beneficial to you. You would ask yourself, how many times do I go across this bridge? And then see if it matches the equation. So once again, if I stay at 10 or less, purchasing the discount will not be beneficial to me. But if I'm going over 10, that's when it will be beneficial because after that, I'll be paying that $4 each time versus paying $7 each time. And that's why I would be good to go. Questions. This class at what? 11. Oh, we got plenty of time, don't we? All right, let's at least do one more word problem. This one's shorter. So it says your local computer store is having a sale on digital cameras. After 40% price reduction, you purchase a digital camera for $276. What was the camera's price before the reduction? All right. So we can set this one up a little different because we do this one. We already know how this equation is going to be set up for us. There are three pieces to this if you think about it, right? So we have the original price. And then we're going to minus the price reduction. Then that would be equal to the sales price. All right, so there's no other way to do that. You know, if you're talking about sales price, you know, retails, you know, if you've ever done retail, you know, you're gonna have your original price, you're gonna have a price reduction, so you minus that, and then you'll have the sales price after that. All right, so let's fill in the pieces accordingly. The original price is what we're looking for, so we can call that X. Sales price is given to us, which is $276. All right, so now the key here is this piece where a lot of people make a mistake on, so be careful with it. So there's a 40% price reduction. As a decimal, that's 0.40 or just 0.4. Now your percentage cannot stand alone. Normally it's 40% of something. Of in mathematics means multiplication. So you're talking about 40% of something. And you have to remember the only thing that we had originally is the original price. So the price reduction is 40% of the original price. So there's going to be 0.4x. This represents 40% of the original price.
So why did you put the X beside it again?
Because X mean because right here when it says 40% of the original price, when you translate that to mathematics, that 40% is the 0.4 of is multiplication. And then what was the original price? So what did we call the original price? That was X. See, we don't know what the original price is yet. So we don't have a choice but to call it X. So that's why we wrote the X right here, because it's 40% of the original price.
Got it, thanks.
Problem. And that's a great question because you have to be careful here, because what a lot of people like to do is they'll do 40% of this 276. They'll put 0.4 times 276. And you'll get close. I've seen people get close to the answer doing stuff like that, but to actually
Yeah, that would
right?
that would be something that I do. I would have did something like that.
And I say stuff like that because I want people to understand that they're in a common place. They're not on the island thinking weird, and they're like, it's a common mistake. So yeah,
Right.
it happens, trust me. But yeah, so we have to do, and like I said, if you think about the rationale, if you're going to take 40% of something, the only thing that existed initially was the X. This doesn't happen until after you do the calculations. So yeah. All right. So any questions before we go with some? Everybody good? So now we have to be careful. Another mistake on this type of problem is because we need to combine our like terms. And so a lot of times people forget that there's a 1 sitting in front of you. So what we're going to do, combine these like terms, we're actually doing 1 minus 0.4. That's actually going to be 1 minus 0.4, which will give me 0.6. So combining those like terms, I'll be left with 0.6x equal to 276. Mhm. Any problems before we look to finish off what we have here? All right, so to finish it off, divide both sides by 0.6. 0.6 is canceled. X is equal to 4. That was all wrong, thinking all wrong.
Is that a 9? Oh, okay.
Yeah, I was thinking wrong. So it's 460. Yeah, because it's 36 and 6. I don't know what I was thinking. I'll put the 9. I think 4 times 9. Yep, I see what I was doing. But all right, so 460, and that's our original price. Questions. Let's scroll up. All right, I wanted to label, I'll label this. Let's see, that was number of crossings per month. So we're just trying to stay consistent with these notes. All right, so we can pause right here. Just because I don't want to get too far away from my last class. I'm trying to keep all my classes in the same spot. And so we have like 2 problems, 2 scenarios. We're getting into solving for specialized variable in the next class. Still in 6.3, so we'll finish off 6.3 next class and then get into graphing. All right, any questions? Everybody good before we close out? Straight. All right, so you guys have a good one. Be safe. Try the stuff out. See if you have any questions, and see how we have room right now for questions. So you'll always have the opportunity. I'll try to make sure that we have the opportunity to ask questions, and go from there. Oh, don't forget. Don't forget. Check out Math Lab. People were asking about their due date. I did adjust chapter 6 and 7 because it's only 5 sections. Chapter 8 and 9 to February 20th. That's the 5th week grading period cutoff, which I have to have grades in by. That should be correct anyway, but that's what it's changed to. So 6, 7, 8, and 9. That's in there. I had a lot of people asking me about. They kept asking about those due dates, so it's there now. Also get into Math Lab. I got like 30 people on roster, and there's only like 14 people in Math Lab, so you got to get in there. It don't cost you anything. Y'all already paid for it, so get in the Math Lab and let's get started so you don't get too far behind. All right, you guys have a good one. Be safe, and I will see you on Thursday.
All right, have a great day.
Thanks for the same. Take care.